Okay, in this video we are going over numbers 7 through 12 in your test review. So number 7, figure S, the small arrow, was dilated with the origin as the center of dilation to create figure T, the large arrow. Which rule best represents the dilation that was applied to figure S to create figure T? All right, so there's a lot of ways that we can look at this problem. So first of all, if I want to know how figure S was dilated to get to figure T, I have to remember that a dilation is about multiplying by a scale factor. So it's multiplying to get bigger. So I'm looking at, is it getting bigger or smaller? So if it's getting bigger, I know that my scale factor needs to be greater than 1. And if it's getting smaller, I know my scale factor needs to be smaller than 1. Well, I can see to get from S to T, it's getting bigger. So if it's getting bigger, I can get rid of B and C. So I want to know, is it getting 2 times bigger or is it getting 4 times bigger? So I'm going to focus on one coordinate and look at how it's getting bigger. So this coordinate, my y value is 3, and it's going from a y value of 3 to a y value of 6. So I can see that what it's multiplying by is 2. To multiply by 4 means it would go to 12. Well, it's going to 6. So I'm going to choose A as my answer, telling me that my x value is being multiplied by 2 and my y value. So let's look at another one so you can see what I mean. So originally, this corner of this arrow was at 2 and 3. And if this rule is right, to get to my new point, it should be, if it's multiplying by 2, at 4. So times 2. And it should be at 6. 4 and 6. So I'm going to go to 4 and 6, and I can see that's where my corner is, so I must have done it right. Number 8, triangle KLM and K prime L prime M prime are shown on the coordinate plane. Which algebraic representation shows how to find the coordinates of triangle K prime L prime M prime? Now, first of all, remember those little apostrophes that I keep saying prime? That means that's my new image. Okay, so I'm going to go ahead and I'm going to trace in green my new image. So once again, I can see it's getting bigger. So KLM is my smaller triangle, and K prime L prime M prime is my new triangle. So it's getting bigger. So it needs to be multiplying by a scale factor that is bigger than 1, while 2/3 is not bigger than 1. It's 0.6 repeating. So I'm going to get rid of B and I'm going to get rid of D. Now, hopefully you should already know that my scale factor must be 3/2. The question is, do I do A or do I do C? Well, I'm never going to have my scale factor first and then end up with x and y. It's always going to be written with x comma y and then 3/2 x, 3/2. But let's look at how we could come about getting this 3/2 if I couldn't have eliminated all my answer choices. Okay, so this time we might not have been able to count as well, but I can see that 2 here for k, so I'm looking at this y value. This same point, when I multiply by a scale factor, ends up at 3 on my y value. So 2 times something is giving me 3. Well, I know since we've learned equations, I could also replace that with x. So 2 times the number is giving me 3, so I'm going to divide by 2 to work backwards. So I know that something I'm multiplying by is 3/2. We've also talked about that as doing my new over original for scale factor. My new is 3. My original is 2. New is 3. A prime. Original was 2. 3 over 2 gives me my scale factor. Number 9, quadrilateral ABCD is graphed on the coordinate grid below. Which of the following points will be the location of C prime after ABCD is dilated by a scale factor of 3? Okay, so I know I'm going to multiply by a scale factor of 3, and my original point is at 3 and 1. So if I multiply by a scale factor of 3, that means I'm going to take 3 times 1, and then I'm going to do 1. I'm sorry, let me rewrite that. I did that wrong. A scale factor of 3. I know I'm going to take 3 times 3. This being my scale factor. And then I'm going to do 3 times 1. Again, this being my scale factor. So I'm taking both of my x and y values and multiplying by 3. So my results would be 3 times 3 is 9. 3 times 1 is 3. So my results would be 9 and 3. So I'm just going to imagine that for a second. So if this was at 3 and 1, for it to expand, it needs to be at 3 and 1. It needs to be at 9 and 3. So 9 and 3 would be way out here and up here, which makes sense because I'm going to stretch it out. Number 10, which mapping represents a function? So now we're in the identifying functions section. Remember, a function is when each input is paired with only one output. So each x has one y. But I really could write the coordinates for each of these, and there would only be one x for one y. So for example, here I have 1, 1, and then I have 2, 1, and then I have 2, 2. So here's the problem, is that this here has 2 y values of 1 and 2. So this is not a function. So this is not my answer. Looking at C, I can see, again, the same problem as I did on A, that 2 has 2 outputs, 2 and 2, and 2 and 3. Not my answer. Looking at B, I can see 1 has 2 outputs, 1 and 1, and 1 and 3. And looking at D, I can see 1 has 1 output, 2 has 1 output, and 3 has 1 output. So D is my answer. Number 11, which statement best describes the two tables below? Table A represents a function, but table B does not represent a function. Okay, so table A represents a function. Well, let's look at table A. Does table A represent a function? 2, 3, 4, 4. Does each input have one output? Well, 2 has one output, it's 7. 3 has one output, it's 5. But 4 has an output of 2 and 3. So if I were to do a mapping of these, I could see that it would look like this. Where 2 arrows are coming out of 4. Okay, so that means that table A is not a function. So A can't be my answer because I want which statement best describes the two tables. Well, table A does not represent a function. Okay, so let's keep going. Table B represents a function, but table A does not. Well, you're right, table A does not. So let's look at table B. 1, 2, 3, and 7. Okay, so those are my inputs, 1, 2, 3, and 7. And 6, 6, 6, and 6. So my output for each of them is 6. But 1 has one output, 2 has one output, 3 has one output, and 7 has one output. So that means this one is a function. So let's read this one again. Table B represents a function, but table A does not represent a function. Well, yes, table B does. So that must be my answer. Number 12, which statement best represents the following graph? The graph represents y as a function of x because it passes the vertical line test. Okay, so let's think about our vertical line test. Our vertical line test helps us see inputs, outputs for those inputs. And anytime my vertical line graph or crosses my graph, that's an output. So all of these represent outputs, and I only want one output on each vertical line, or my inputs. So I can see anywhere I draw a vertical line, I only have one output. There's only one point on each vertical line. So that means this is a function. So let's read again. The graph represents y as a function of x because it passes the vertical line test. That seems true. Let's keep reading. The graph does not represent y as a function of x. That's not right. The graph represents y as a function of x because it passes the horizontal line test. No, we don't do horizontal lines. And it wouldn't pass a horizontal line test anyway. So no. The graph does not represent y as a function of x. Does not, no, that's not true. We know it does. So A is my only possible answer. So that's the end of video 2. You should be through numbers 1 through 12 of your test review.